In this video, we're going to do a theoretical probability example where we look at a deck of cards. And this is a picture of a deck of cards. So if you're not familiar, this might be something that you might even want to print out if you can. So there are 52 cards in a standard deck of playing cards, and there are 4 suits, and those just refer to the rows here. So all of these where you see this, it looks like a 3-leaf clover. This stands for clubs. So this entire row is clubs. So you say like this card, for example, is the 8 of clubs or the queen of clubs. This row is diamonds. This row is hearts. This row is spades. And there are different either numbers or letters written on each card. So these are, all aces. And we have jacks and queens and kings, which are all called face cards. So face cards are any cards with faces on them, and it's hard to tell in this picture. You can also look up a picture online if you want to see one a little bit closer, but there are pictures of actual jack, queens, and kings on all of these cards with faces. So think of face cards as just faces. So there's 12 of those altogether, all of these. And so let's think about some of these examples. So let's look at A. And it's important to note before we start that with all of these examples, the denominator is going to be 52 because there are 52 cards in a standard playing deck. So in this example, we're just going to count how many jacks are there. Well, there are 1, 2, 3, 4 jacks. So the probability of getting a jack is 4 out of 52. And then let's talk about how we could reduce this. So you could find a common factor. In this case, both of these are divisible by 4, which gives us 1/13. If you are not great at reducing fractions, if you have TI-34 or 30, you can use the fraction button and just punch in 4 over 52 and then hit the simplify button. And you're going to hit the simplify button until you see a factor of that simplified, but it doesn't hurt. Just keep hitting it until you see this factor of 1, and then you know you've gone far enough. So you get the 1 out of 13. If you have a graphing calculator, I'll show you how to do that. What you can do is you can divide 4 divided by 52 and hit the math button. So math, enter, enter. And so you get 1/13. And then you can see the decimal over here. If we were to write down the decimal, let me pull that back up. You would end up getting 0.0769 for the decimal for that one. So we can write that down as well. Okay, and on this calculator, if you want to do the decimal, you can also just do 1 divided by 13 and get the decimal that way. And so for B, the 6 of clubs, in this case, well, first I'll go ahead and erase those last 4. And we'll count how many cards have a 6 and a club on them. So we can look down the club row. There's only 1 6 of clubs. So in this case, the probability is 1 out of 52. We can't reduce that anymore, but we could write down the decimal. So say you were asked to round to 4 decimal places, you could write 0.0192 would be the decimal equivalent for that one. And then a 3 or a diamond. Okay, so in this case, whenever you see the word or in a probability problem, you are going to count either of them. So if it's a 3, you're going to count it. If it's a diamond, you're going to count it. If it's a 3 of diamonds, you're going to count it. So if any of these characteristics occur, you count it. So we could go down the 3s and say 1, 2, 3, 4, and then we could count the diamonds. 5, 6. Now notice I already counted this diamond. I'm not going to double count it. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 out of 52 cards that have either a 3 or diamond. Again, we don't double count that card that is both 3 and diamond. And then we could reduce these. So we could reduce these by dividing these both by 4 and getting 4 out of 13. Or again, you could do the N over D button, 4 over 13, and hit that simplify key. And keep hitting it until you get that factor of 1. We could also find the decimal, so 4/13, and we get a decimal of let me get my pen working here. There we go, 0.3077 for that one. Okay, so let's look at some more. So just like the last set of 3, all of these are going to be out of 52. Because we have 52 cards in the standard deck of playing cards. So this first one, what's the probability of picking a 4 or a 6? So or means that I count either the 4 or a 6, or if there were a card with both, in this case there's not. So I go up to my sample space and I just start counting. So there are 1, 2, 3, 4 cards that are 4, and then 5, 6, 7, 8. So 8 altogether that are either a 4 or a 6. And so I could reduce by dividing both by 4, which gives me 2/13. And I could just say 2 divided by 13 to get the decimal. And that gives me, if I were rounding to 4 decimal places, 0.1538. And then I can also use the fraction button, 8 over 13, or sorry, not 13, we're 8 over 52. And then hit the right arrow and then simplify. And we're going to keep hitting simplify until we see a factor of 1. And you can see we get 2 over 13ths that way also. For E, we're going to look for all of the face cards. And so those are cards that have faces on them. So all the jacks, queens, and kings. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 face cards in the deck. And we can reduce that by dividing by a common factor of 4. And that gives us 3 over 13. Or we can use our calculator and do it that way. And then hit the simplify button until we get 3 out of 13. And then we can also divide to find the decimal equivalent of that. And so the decimal equivalent is 0.230, in this case 8 if we round to 4 decimal places. So always just pay attention to your problem and the directions and how it asks you to round. For F, we're asked, what's the probability of not getting a king? So you can do this one in a couple of different ways. You could count all of the different cards that are not kings. That would take a while. So we could do that real quick. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So we count all those and we get 48 out of 52. And we could reduce that. We could divide both of these by 4. And we end up getting 12 out of 13, and we can find the decimal for that with the calculator. The other option, we can use our rule of complement. So the probability of a complement and the complement of an event is just 1 minus the probability of that event happening. So if there are 4 kings out of a deck of 52, then we could think of this as, well, how many cards are not king is going to be a complement to how many cards are king. So those are complementary events. And so if we say the probability of not getting a king could be 1 minus the probability of getting a king. And so picking a king, that's a little bit easier to find. So we know there are 4 kings. That's faster to count. And so we could just do 1 minus 4 out of 52. Okay, and 1, if we got common denominators, is just 52 out of 52. So 52 out of 52 minus 4 out of 52 is just 48 out of 52. So basically, you could do it how we did in the beginning, and we just counted all of the cards that are not king. We got 48, and then we reduced. So our reduced answer is 12/13. That's the final answer. Or if we didn't want to count all of the cards that are not king, we could count the cards that are king because it's faster, 1, 2, 3, 4, and just subtract that probability, 4 out of 52, from 1 to give us the probability of not getting a king. So you have some options there depending on how much you want to count. And then we could use our calculator and just divide 12 by 13 and we get a decimal, so 0.923. This would round to 1. And so you can see here, if we talk about percent chance, that's like, a little bit more than a 92% chance of getting a card that's not a king. So in example G, we're looking for the probability of a club or not a face card, and it's going to be out of 52, as is example F, because there's 52 different options. So let's go ahead and we can just count how many cards are either a club or not a face card. So the easiest way to go about this is to first just count all the clubs. So there are 13 of each suit, so we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 of those, so 13 different clubs. And then we also want to count all of the cards that are not face cards. And we don't want to double count. So any card that is not a face card, so we don't want to count these over here, would be like, the 10 of diamonds. This is not, all of these cards are not face cards because they don't have faces on them. And so basically what we would do is we would go through and we would count all of these other different options that represent either a club, so this whole row, or not a face card. Now notice there were 3 face cards that I ended up circling, and that's because those happen to be a club. And so the word or, that means either or. So if it's a club, even though it doesn't fit this description of not being a face card, we still circle it. And so we have 13 in the first row, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. So there are 43 cards that are either a club or not a face card. And we can't actually reduce that, but we can put it in our calculator to find the decimal. And so we get a decimal of 0.8269. And if you weren't sure if this was reducible, you could use your fraction button and just do 43 over 52. And then when you hit the simplify button, you get 1. We could also do that on the graphing calculator. Show you how to do that. So you can divide 43 divided by 52 and then hit math, enter, enter, and notice you get the same fraction that you started with. So that just tells you that, there isn't a fraction or a reduced version of that fraction. Okay, so let's look at the next example. So the next example, we're trying to find the probability of a club and not a face card. So we're going to look at all of the different options. Well, it's basically the same question as what we did before, except for one big difference. So notice here there's an and, whereas before there was an or. So or means we want to count both, any card with either of the characteristics we count. And so you can see that, we counted even these face cards over here that were clubs because they fit that club description. And so in this case, we can only count the card if it is a club and it is not a face card at the same time. And so it's going to be very similar to what we counted last time, except there's a couple that we're not going to want to count. And the ones that we're not going to want to count are these face cards over here. And so we definitely don't want to include anything that's a face card. So I'm going to erase those. And it has to also be a club. So I'm going to erase all of these other suits have to go because I can only circle it if it is a club and it's not a face card. So the only cards that are a club and not a face card are these 10 right here, because all of these cards have clubs on them, and all of these cards are not a face card because they don't have any faces on them. They're not a jack, queen, or king. So if we count those, we get 10 out of 52, and we can reduce this by dividing both of these by 2, and we get 5 out of 26. And we can find the decimal for that, 526. And we end up getting 0.1923, which as a percentage, if we want to know the percent chance, is about a 19% chance of happening.